Hi, good afternoon. Yes. Starting now. Oo, dun ka na, babe.
Don't mess with me.
Ha? Hello, guys. Hello, patatas. One person watching. Anybody there? Ano to? What's this?
Those are the words.
Sige na, ikaw na.
Those are the words.
Hinaan mo yung TV mo. Hinaan mo yung TV mo. Where are you? Okay, anyway, since you are not required to be um, really present during the live discussion, it's fine. So I will just be starting now with the discussion. So if you're here already, so kindly let me know. Yeah, because I don't know if anybody's here already in our live discussion. So good afternoon. So I hope you had a good lunch because I just had mine. Okay, so for this video, we will be discussing two processes or two steps rather in the tissue processing. So that would be impregnation, and then the other one would be embedding. Okay, so after performing clearing, so the next step in the routine tissue processing that we perform in histopathology would be infiltration and embedding. Okay, so the reason why we are discussing it um, together is because of the fact that the reagent which is used in impregnation is most oftentimes the same reagent that we use for embedding. Okay, wait a minute. I'll just check something. All right. Anyway, yes. So let's start now with impregnation first. So let us define what are these two processes: impregnation and embedding. Okay. So first we have impregnation. So when we say impregnation, okay, so it is the process of completely removing the clearing agent from the tissue and replacing it with a medium in order to completely fill the different cavities, spaces which are present in your tissue sample. Okay, so what are the different purposes of infiltration? So, by the way, when we say infiltration, it is the same thing as impregnation. So, we use these two terms. Ano na nga ba yun? We use these two terms. We can use we use these two terms to refer to the same procedure in tissue processing. I'm sorry, I forgot the term. Ano na nga ba yun? Okay, anyway, first we have impregnation. So since we already defined it, so what are the different purposes of impregnation based on the definition that we gave a while back? So first, okay, purpose, okay, from the definition itself, you have to remove the clearing agent. Okay, you have to remove the clearing agent completely from your tissue sample. Otherwise, it will affect um, the consistency of the tissue sample later on. Okay, another purpose of impregnation is to be able, kasi naman, bakit kasi kinuha mo pa?
I was just gonna put it
No, because I'm gonna use it, right? Okay, put it there. Okay, so another purpose of infiltration or impregnation is for us to be able to fill the different cavities, the different spaces, and interstices which are present in your tissue sample. So why do we have to fill it, to fill your cavities? Um, Filling up your cavities with cavities and spaces with your impregnation or with your infiltrating medium will make your tissue sample firm. Okay, so that's the other purpose of your impregnation or your infiltration to render a firm consistency to our tissue sample. So a firm consistency of our tissue sample. So this will make it easier for us to cut and handle our tissue samples later on when we go to embedding and then when we go to your um, sectioning or microtomy. Okay, so I have already mentioned three purposes. The first one is to remove the clearing agent. Another one is to be able to fill the cavities, the spaces, and the interstices. And then lastly, to render a firm consistency to our tissue sample for easier cutting and handling. Okay, and the last one, okay, this is particularly true if we are talking about paraffin wax embedding. Okay, I'm sorry, paraffin wax processing. So that would include impregnation and embedding. So it will allow us to store our processed tissue samples. Okay, so this is an additional purpose of impregnation or infiltration if we are to consider the use of your paraffin wax. Okay, so it will allow us to store the processed tissue samples. Okay, so that will be for impregnation, otherwise referred to as infiltration. So next step after performing infiltration or impregnation, we have embedding. Okay, before we go to that, I just recognize the presence of our honorable Vice President, Christine Grace Officiar. Okay, so she's present already. Miss Janlay Valdez is also present. Okay, dalawa lang sila. Tatlo kami dito. Okay, anyway, um, yes, so let us now move on to the next step, and that would be embedding. So when we say embedding, other terms which are used to refer to this would include your casting, or would include casting or blocking. Okay, so what do we perform during the embedding process, or what is this process in? No, okay, what does this process entails us to do. So when we say embedding, so this is or this involves your impregnated or your infiltrated tissue sample, which is placed precisely in a mold with a medium. Okay, so I repeat, when we say embedding, this is a process wherein your impregnated tissue sample is placed precisely, it says there, in a mold with a medium. Okay, so when we say precisely placed, okay, we are already emphasizing the importance of proper orientation during embedding. Okay, so that means orientation of your tissue sample, your infiltrated tissue sample, is a very important step when we perform embedding. If you are not able to properly orient your tissue sample, so this will, of course, affect um, the tissue section, which is to be examined and interpreted by our pathologist later on. So, say for example, if you are to um, produce, okay, or if you are to make cross sections of a hollowed organ, for example, a hollowed organ, for example, however, you were not able to make the proper orientation during embedding, so of course, this will affect, okay, the examination and the interpretation later on of the pathologist. Okay, so that's why one very important step incorporated in our embedding procedure would be proper orientation. Okay, so may I just also recognize the presence of Miss Carla and Miss Cherry May. Okay, hello, good afternoon. All right. So I hope the definitions and purposes of impregnation and embedding are clear to you. And so let us move on to um, the different, okay, the different types of embedding media that we can use in order for us to perform infiltration and impregnation. Okay. So please do not be confused when I make use of the term embedding media, infiltration media, because just like what I have mentioned at the start of our discussion, when we say um, infiltration and embedding, in most cases, we make use of the same reagent. Okay, so when I say infiltration media or embedding media, I am referring to the same group of reagents that we use in histopathology. Okay, so what is an infiltrating or an embedding media or medium? Okay, so this is a reagent that we use to infiltrate, to support, and to enclose a tissue specimen. Okay, so the embedding, the medium that is used for impregnation and embedding should be the same. Okay, should be the same. In most cases, it's the same. Okay, so why does it have to be the same? It has to be the same because we want to achieve, okay, a similar or the same consistency of your tissue sample and your blood. Okay, so that means the hardness, okay, the hardness of your tissue sample should be the same with that of your blood. So that later on, when we perform sectioning, it will be easier for us to have thin slices of your tissue sample. So just imagine if you are going to make use of gelatin, for example, or paraffin as the infiltration medium. And then for embedding, you're going to make use of gelatin. Okay, so say for example, ganon. For infiltration, you make use of paraffin, and then uh, for for embedding, we make use of gelatin. So we all know paraffin. It has almost, yeah, it has almost the same consistency as the candles that we have, the normal candles that we have in at home. And then for gelatin, again, of course, it has almost the same consistency as that of the gelatins that we have at home. So if you compare the consistency of these two, they're very different. Okay, they're very different. And so, hindi din sila parehas ng consistency. Okay, so how are we going to cut your or how are we going to make thin sections if you don't have the same consistency? Okay, it's like eating a gelatin with pineapples in it, for example. Diba? The pineapple itself will have a different consistency as that of the gelatin. And so when you cut it, you will not really be able to cut it properly or easily. Okay, so yeah, that's the closest analogy that I can think of when it comes to why. Okay, the infiltrating and embedding medium, or yes, should be the same. Okay, yeah. So what are the different types of embedding media? I'm sorry, it's a little bit noise because the boys sa taas, they're playing basketball. Okay, but anyway, yes, so please bear with me. I hope my voice is louder. So for those who are present, is my voice louder than the noise? Than the noisy people around? Mm. How do I cancel the noise? Because there's no cancellation for this one, I think. Right? Okay, wait a minute. Anyway, yeah, I don't know. Maybe I will learn later on as we go along our online discussions. All right. So anyway, what are the difference? Okay. So thank you, Miss Carla. Maganda yung boses ko. Ha? Maganda. Okay naman. Same lang sa classroom. Ay, niyo ako. Answer me. Okay, thank you, Miss Cherry. All right, so let's continue. Um, what are the four general types of media that we can use in histopath? So first, of course, we have paraffin. Okay, we have paraffin, which is the most commonly used infiltration and embedding or infiltrating and embedding medium in the laboratory. So in addition to paraffin, okay, in addition to paraffin, we also have celloidine. Okay, celloidine, this is otherwise referred to as collodion. Okay, I think we have already talked about celloidine or collodion when we were talking about decalcification in the lecture, right, during our previous meetings. And so you are a little bit familiar about it already. Um, Celoidine, okay, in histopath, aside from using it in order to ensure that our tissue sections adhere to our slide, okay, during or after performing decalcification, we also use it as a general type or as a general type of medium in the laboratory. Okay, so in addition to celloidine and paraffin. We can also make use of gelatin. Okay, gelatin. And then lastly, we have plastic, which is my favorite embedding medium, plastic. Okay, so here in histopath, you will encounter a lot of plastics. Okay, so later on, we will be discussing what are the different types of plastics and why. Why why is it my favorite? Okay, so later we will discuss that. All right. So um regardless of the embedding medium that we use in the laboratory, okay, regardless of the embedding medium that we use in the laboratory, one important characteristic or the most important characteristic of your embedding media. Okay. The most important characteristic of your embedding media should be that it is capable, okay, of being converted readily from liquid to solid form. Okay. It should be convertible from liquid to solid form. Okay. So why? Of course, why? I always ask why? Because I want you to know the reason. It's very difficult to remember something if you do not know the reason why. Why should I memorize this? Why is it like this? Okay, so that's why for me talaga the most important thing in learning is to know the reason why. In everything that we do, we should always know, we should always know the reason why. Okay? So, yan. Why is it the most important characteristic? Because the liquid form, the liquid form of your embedding media, this is important during the infiltration process. Hmm? How are you going to infiltrate your tissue sample if it is not in liquid form? That's why in the laboratory, right before that our classes got suspended, what did we do? What did we do? We melted our paraffin, right? Because we want it to be in its liquid form for infiltration. How can something infiltrate if it's not liquid? Okay, this is in the case of histopath. How can someone tuloy, how can something impregnate, okay, if it is not in liquid form? Mm-hmm. Okay. Okay. All right. Yes. So that is the importance of the liquid form. And we have additional students. We have Clyde. We have Miss Rose. And parang may isa pa kanina. Okay, anyway, sila lang, dalawa ang additional. So, hi to Sir Clyde and Mom Rose. Okay? Ayan, welcome. Miss Angela is also present. Ayaw patalo. Okay, Miss Angela May Bonilla from Pangasinan is present. All right. So now we understand why do we need the liquid form. Okay, now what is the importance of the solid form of your embedding media? The solid form is important during the embedding process. Remember, what's the other name of embedding again? Blocking. Okay, blocking. Miss Pauline Santos, hello. I think Miss Pauline is from Nueva Ecija. Oh my gosh. And Carlozon is here. Okay, do we have students from the Visayas region, from Mindanao? Oh, okay, anyway. Yan. Why? Why is the solid form important? So again, the solid form, okay, of your embedding media is important during embedding. So just like what I mentioned, what is the other name of embedding? It's blocking. Blocking. From the word block. Okay, block. 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 Ice cube. Oh, parang cube. Diba? Block. You have to be able to produce a block. Block. Okay, block at the end of the embedding process. How are you going to do that if it's not convertible to solid? Come on. Diba? All right. Yeah, so that's why your embedding medium, it has to be liquid for infiltration, converted to solid during the embedding process. Okay? Ma'am, may nakasilip sa likod. Sino? Likod ko? Wala. Yung ano lang yun, kurtina. Walang nakasilip. Okay, let us please recognize the presence of Mr. Korea, King Sadoy. Hi, Sadoy from Korea. You go there na. Sige na. Isa, bye. Alright, so yun po. Okay, so I hope everything is clear to you. So depending on the media or the medium that we are talking about, so there are several mechanisms involved in the conversion of your embedding medium from liquid to solid. Okay, so first let us discuss what is the first mechanism. So the sorry, lunch. Okay, the first one is crystallization. Okay, crystallization. So this is the type of solidification process that is seen in paraffin as well as carbowax. Okay, so I repeat, the first one, we have crystallization. So examples of embedding media that undergo crystallization to solidify would include your paraffin and carbowax. Okay, another would be evaporation of solvents. So particularly in the case of celloidine, okay, in order for us to have the liquid form of celloidine, you have to dissolve it in solvents. So that's why in the case of celloidine or collodion, the mechanism of solidification would involve the evaporation of the solvent that is incorporated in your celloidine. Another mechanism would involve polymerization. Okay, so we are very much familiar with the term polymer. Okay, so this is seen when we make use of plastics. Okay, plastics. Nagpo-polymerize ka ba? O, di plastic ka. Okay, anyway, yeah. So polymerization, we have plastic. So do not forget the different mechanisms, okay, of solidification of the different embedding media that we use in histopath. Okay, yeah. So now let us move on to the different media. Okay, first, just like what we have been doing in the other tissue processing, or in the other steps in tissue processing, the first reagent that we discuss would be the one that is routinely used. And we will also be doing that in the case of infiltration and embedding. So guys, if you have any questions, it's fine. You can just type it, or if you have any comments regarding our live discussion, so please feel free to type in your comments and your questions regarding the things that we are discussing. Okay, so that everything will be clear. So that is the most important thing. That's why we have discussions. Hindi pwedeng ano din dito, hindi nagsasalita. Or you have to actively participate also in our online discussion. Okay? Yan. So, first off, we have paraffin processing, paraffin impregnation. That's so your paraffin impregnation, it is considered to be the simplest. Okay, it is considered to be the simplest. It is the most common and it is the best for routine processing. So I repeat, it is the simplest, most common, and it is the best for routine processing. Okay. So first, what are the things or what is one thing that you have to remember? Remember, the 5th of November. Remember when it comes to paraffin or to waxes, to reagents. Oh, ano yung kailangan nating alam? Remember when we were talking about dehydration, the most important or one factor that you have to consider would be concentration, right? 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 Okay. And then for paraffin, or no, not really just for paraffin, but for impregnation in particular, impregnation and ano na yung isa, and embedding. Okay. You have to take note of the melting point of your waxes. Okay, you have to take note of the melting point of your waxes because all of these processes, okay, all of these processes that we perform, all of these steps that we perform in tissue preparation would be for us to produce a tissue section. Okay, a tissue section that is of diagnostic quality. So, um, what is a tissue section muna? What is a tissue section? Tissue section. A tissue section is a very thin, it's a very thin slice of your tissue sample. Okay, of your tissue sample. Very thin slice of your tissue sample. May I emphasize on thin? Okay, because what we want during sectioning in general would be to have a thin section. Why do we have to perform dehydration and clearing? In order for us to make your tissue sample compatible for yes, in order to make our tissue sample compatible to the reagent that we use for impregnation and embedding. Now, why do we impregnate or and embed? Impregnate, embed, impregnate, embed, bed. Okay, why do we impregnate and embed? We impregnate and embed in preparation for sectioning. Okay, in preparation for sectioning. So what is the effect of your melting point? When we say melting point, it will affect the hardness, okay, of the block, okay, and of course that's the tissue later on. Okay, so I will repeat, it will affect the um the the tissue sample as well as the block. So the higher the melting point, the harder the wax. Okay? The harder the wax, the thinner your sections are. Okay, I repeat. The higher the melting point, the harder the wax, the thinner your sections are. Okay? Yan. So please do not forget this very important rule as for the reagents that we use for impregnation and embedding. Okay? Yan. So apart from the melting points or in the case rather of paraffin, okay, in the case of paraffin, common waxes which are available for use in the laboratory would have the following melting points. Okay, would have the following melting points. I have a very large whiteboard, so that's why it's very difficult for me to write Okay. So common waxes which are utilized in the laboratory would have the following melting points. Okay, so first we have 45, 45 degrees Celsius. Okay, degrees Celsius, there's degrees Celsius here because we are talking about melting points. So apart from 45 degrees Celsius, we also have 52, 45, and then we also have 52 degrees Celsius, and then another we have 56, and then lastly we have 58. Okay, so these are the melting points of the common waxes that we use in the laboratory. So out of these four common waxes, okay, out of these four common waxes, the one that is most commonly utilized wax in the laboratory would have a melting point of 56. Okay, 56 degrees Celsius. Okay, we have 56 degrees Celsius. Right? Yeah. Okay, so that's for the melting point of our paraffin waxes. Okay, so what are the different factors that we can, Maddox, can you please erase? Okay, what are the different factors that we have to consider in choosing the right type of wax? It is this everything, okay? So what are the factors that we have to consider when choosing the paraffin wax to be used? Okay, so the first thing that we have to consider would be the laboratory temperature. Okay, the laboratory temperature. So basically, there are two laboratory temperatures. Okay, two common laboratory temperatures. So first we have 20, okay, 20 to 24 degrees Celsius. Okay, so this is in our PowerPoint. So if the laboratory temperature is 20 to 24 degrees Celsius, the melting point of the wax should be 54 to 58 degrees Celsius. Okay, so I repeat, if the laboratory temperature is 20 to 24, then the melting point of the wax should be 54 to 58 degrees Celsius. Another, what if the laboratory temperature is between or is 15 to 18 degrees Celsius? Okay, so if the laboratory temperature is 15 to 18 degrees Celsius, then we make use of a wax. Okay, the wax that is to be utilized should have a melting point of 50 to 54 degrees Celsius. Okay, so I repeat, the melting point of the wax, if the laboratory temperature is 15 to 18 degrees Celsius, we have 50 to 54 degrees Celsius. Okay, ma'am, cute. Ano yun? Cute, ma'am, pa-shout out po. Okay, shout out to our Mr. South Korean, King Sadoy. Hi, Sadoy. Okay na? Okay na. Masaya ka. Okay. Okay. Yeah, so we have here a question from Miss Cherry May David. So, Miss Cherry, sabi niya, ma'am, ano po yung 56 degrees Celsius? Okay, 56 degrees Celsius is the most commonly used wax in the laboratory. So, remember, just like what I mentioned a while back, we do not classify our paraffin wax based on other characteristics. Okay, we classify our paraffin wax based on their melting point. That is the most important characteristic that we have to consider when we are trying to classify our paraffin waxes. Okay, so common waxes. Ulitin natin. Common waxes available in the laboratory will have a melting point of, again, chorus. Maddox, erase. Wait lang erase natin. I need you. You're my eraser boy.
I'm just
Okay na? Okay, thank you so much, eraser boy. Alright. So, common waxes po that are used in the laboratory would have melting point, would have a melting point of 45. Okay, 45. And then 52. 52. What else? We have 56 and then 58. Okay. So 56, this is the most common. Okay? Most common. So these are the common waxes. Common waxes, 45, 52, 56, 58. Most common, 56. Most common is 56. Okay? Most common. Ooh, Emily. Okay, most common. Okay? Oh, Maddox, kindly, please. Thank you. And then erase it. Okay. Ayan. So, again ha, back to the factors that we have to consider. Laboratory temperature. Laboratory temperature of 20 to 24, that is the melting point of the wax. 54 to 58. Laboratory temperature of 15 to 18 degrees Celsius. What should be the melting point of the wax? We have 50 to 54 degrees Celsius. Okay, degrees Celsius. Yes, actually that's the hard part uh whenever I discuss impregnation and embedding. We have to consider, you have to memorize a lot of temperatures since the melting point is really a very important characteristic in this case. Okay? Yun, yeah, I'm sorry, but you have to memorize a lot of temperatures in here. Yes, a lot of temperatures. Okay. Anyway, yeah. So apart from the laboratory temperature, so what else do we have to consider? We have to consider how hard your tissue sample is. Okay, how hard your tissue sample is. What is our rule again when it comes to the hardness of our paraffin or our impregnating and embedding media? Ano ang rule natin? The rule is the higher the melting points, the harder the wax. Okay? And so, if hardness of tissue is one factor, what will be our general principle in this case? For hard tissues, this would require paraffin wax which will have a higher temperature. Okay? So I repeat, hardness of tissue, the harder the harder the tissue sample, the higher the melting point of your paraffin wax. Because high melting point corresponds to a hard paraffin. Nako ha, harder, higher. Okay, melting point. Harder tissue, higher melting point. Okay? Yan. And of course, okay, since your tissue is hard, you make use of high melting point of paraffin wax, then what becomes of your block? Your block will also become hard. Tama? Your block, the block that you produce after embedding would also be hard. Okay? And it will determine the type of microtome that you use later on during sectioning. Mm, these are all connected to one another. So that's why I always emphasize that you have to understand compatibility. Okay? If it's compatible, or look for something that is compatible. If it's not compatible, then okay. How? Diba? Oh, okay. Compatibility is the key here. All right? So again, hard tissues, higher melting point of the wax. And then the block that you produce is hard. Okay? For hard blocks, we make use of heavy duty microtome. Okay? We make use of heavy duty microtomes. So later on, when we will be discussing microtomy or sectioning, I will also be mentioning what are the different heavy duty microtomes that we can use if the block that we are cutting is considered to be hard. Okay? Yan. Alright. So for the temperature that is required for paraffin impregnation is 2 to 5. Okay? 2 to 5 degrees Celsius higher than the melting point of the wax. Okay. So during quizzes, during exams, I will not consider answers. Like for example, what should be the temperature for paraffin impregnation? And then your answer will be 2 to 5 degrees Celsius only. Then that's incomplete. Diba? It's incomplete because 2 to 5 degrees Celsius is different from 2 to 5 degrees Celsius higher than the melting point of the wax. Okay? And so, the unit here is not degrees Celsius. You should include higher than the melting point of the wax. Otherwise, your answer is considered wrong. Okay? Because 2 to 5 degrees Celsius is different from 2 to 5 degrees Celsius higher than the melting point of the wax. Okay, what is the required temperature? 2 to 5 degrees Celsius higher than the melting point of the wax. Okay? Yan. So another temperature that we are considering during paraffin impregnation is 55 to 60. This is the advantage of online discussion because you can't see my my saliva. It's raining saliva. Okay, anyway. Yan. So for the temperature, 2 to 5 degrees Celsius higher. Siyempre, maawa naman na kayo sa akin. Huwag nyo nang ipasulat yung higher. Okay, please have mercy. I don't have to write. But you have to write. Okay? So, 2 to 5 degrees Celsius higher. Ganyan na lang. Higher than the melting point. Okay? Higher than the melting point of your wax. Okay? However, there is also one temperature that we consider. We have okay. The other temperature that we consider is 55 to 60 degrees Celsius. That's why, remember, when I asked you to put your melted paraffin in the oven, what temperature did you see? Okay, the oven is set at 60 degrees Celsius. Okay, because that's the maximum actually. That's the maximum temperature. So, if for example, um, this one, 2 to 5 degrees Celsius higher than the melting point of the wax is not among the choices, then you look for 55 to 60 degrees Celsius. Okay, this is also a correct answer. Between the two, between the two, which one is better? Which one is better? Between the two, which one is better? 55 to 60 degrees Celsius is a better answer. So say for example, in my exam, it says there, A, 2 to 5 degrees Celsius higher than the melting point of the wax. B, 5 to 10 degrees higher than the melting point of the wax. C, 55 to 60 degrees Celsius. D, 60 to 65 degrees Celsius. Then what is the best answer? The best answer is this one. Okay? The best answer is 55 to 60 degrees Celsius. Why? Because if you are going to perform impregnation, at 60 degrees Celsius. That's very hot. I'm sorry, beyond rather. Okay, so I repeat, ulitin ko, feel na feel ko pa naman. Ulitin natin. Okay, 2. If you are going to perform impregnation beyond, more than 60 degrees Celsius, it will be deleterious. Okay? It will be deleterious to the tissue sample. Anong ibig sabihin ng deleterious? So when we say deleterious, it is damaging. Okay? Deleterious. It will be damaging to the tissue sample. Okay? So that's why between the two, this one is better. Because what if the melting point of the temperature that you used in the laboratory is, okay, is, okay, 58. Nakikita nyo ba? Kung hindi nyo nakikita, isulat nyo na lang, okay? So what if the temperature of the melting point of the wax that you use in the laboratory is 58. Okay, 58. Plus 2, that's 60. Plus 5, 63. Okay, and so, if we are to follow 2 to 5 degrees Celsius higher than the melting point of the wax, then the temperature of the oven or the temperature during infiltration should be 60 to 63 based on this rule, right? Based on this first rule. However, again, please take note that beyond 60, it is already deleterious to your tissue sample. Okay? Okay, so that's why this is a better answer, 55 to 60 degrees Celsius, as long as it is higher than your than the melting point of the wax. All right? Okay. Okay, yes. All right. Beyond 60 beyond 60 it is already damaging to your tissue sample. Okay? Yeah. So next, so what are the other factors that we have? Yes, erase please. What are the other factors that we have to consider also or that affects paraffin impregnation? Okay, so the first, another factor rather that we have to consider would be the nature and size of the tissue sample. Okay, so when we say nature of the tissue sample, we are considering the density, how dense your tissue sample is. Okay, how dense your tissue sample is. So for tissue samples which are denser and larger, okay, for tissue samples which are denser and larger, we make use of longer impregnation time and more frequent changes. Okay, so I repeat, longer impregnation, longer duration of the impregnation process, and more frequent changes. Okay, longer and more frequent changes. Another would be the clearing agent that is used. Oh, used. Okay, the clearing agent that is used. Remember when I discussed clearing a while back, okay, I mentioned that the clearing agent that you use will affect the infiltration process. Okay, so say for example, if we compare xylene and benzene, or xylene or benzene versus the use of chloroform or cedarwood oil, okay, which one will have a faster impregnation or infiltration process? It will be your xylene and benzene. Okay, because xylene and benzene are easier to replace as compared to chloroform and cedarwood oil. Okay, sorry. Okay, yan. So I repeat, xylene and benzene, so they are easier to replace as compared to chloroform and cedarwood oil. So that's why the clearing agent that is utilized in the previous step in tissue processing will affect paraffin impregnation. Okay? Yeah. So those are the different factors that affect um, the process of paraffin impregnation, as well as the type of paraffin wax that we have to make use of. Okay, yan. Okay, so now what are the different advantages? Okay, what are the different advantages of paraffin. Yeah, masyadong maliwanag kasi hapon. Okay, anyway, yeah. So what are the different advantages of paraffin impregnation? So the first one, paraffin impregnation and embedding. The first advantage, we are able to produce thin serial sections. Okay, so when we say serial, magkakasunod. Series, in series, okay? Yan. So I repeat, we are able to produce thin serial even sections, okay? So when we say thin serial sections, when you use paraffin wax, you are able to produce sections as thin as 4 to 6 micrometers, okay? 4 to 6 micrometers, this one, 4 to 6 micrometers. So please take note that for routine, okay, routine study of your histologic and histopathologic sections, the required is 4 to 6 micrometers. Okay, this is also the reason why paraffin is routinely used because it ano ba yun? It satisfies, okay? It satisfies the required thickness or thinness, okay, of the section which you are to produce, which is 4 to 6 micrometers. This is, I repeat, the required thickness of your section for routine histologic or histopathologic study. Okay, yan. So another advantage of paraffin processing is the entire process is considered to be rapid. Okay, the entire process is considered to be rapid. So that means from the time that you fix your tissue sample, that you perform dehydration, clearing, up to the time that you have your sections, the entire process, okay, of tissue processing is rapid already. That is already considered as rapid. So sections are prepared within 24 hours. So that means if the tissue sample was submitted today, then you can already have your tissue sections ready for examination and interpretation by the pathologist by tomorrow. Okay, so the entire process is rapid. Okay, so remember ha, in histopath, when we talk about rapid, 24 hours is already considered as rapid. Okay, unlike in the other sections of the laboratory, wherein when we say rapid, it has to be within 15 minutes, within 30 minutes, but it's a different case in histopath because you have to perform a lot of steps before you have your sections ready for examination and interpretation. Okay. Another important advantage of your paraffin is that it permits many staining procedures. So that means, okay, that means your paraffin is compatible with a lot of staining techniques that we use in histopath. Okay, it is compatible with a lot of staining techniques that we use in histopath. Okay, another, just like what I have mentioned a while back when we were discussing the purposes of infiltration is your paraffin impregnation. It allows possible storage of your processed tissue sample, okay, or of your infiltrated or even embedded tissue sample. The storage of this is possible. Okay, storage is possible. Okay, yeah. So another, so these are the different advantages. So now let us move on. What of paraffin impregnation? Okay, prolongation, 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 prolongation. Sorry. You should do that. It's entertaining. Okay. Diba? It's entertaining. Sadoy. Sadoy. Oh. Pauline. 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 Angela. 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 Oh, 'di ba? Nakakaaliw. Yes, 30 days ang quarantine. Kaya you have to entertain yourself. Okay, yeah, it's ano, simple but entertaining. Anyway, okay, prolongation. Okay, prolongation. So when we say prolongation, it pertains to the immersion of your tissue sample for prolonged periods of time in your paraffin. Okay, prolongation will result to excessive shrinkage and hardening. So I repeat, prolongation will result. Sorry, wait lang. Okay, guys, take note ha, take note. Uh, when your tissue sample is immersed in a prolonged period of time, okay, in a prolonged period of time, in any reagent that we use in histopath, it would always result to excessive shrinkage and hardening. Whether we are talking about your whether we are talking about your fixative, whether we are talking about your dehydrating agent, your clearing agent, and now your paraffin. Basta, excessive, prolonged immersion in your reagent will result to shrinkage and hardening. Okay, ano lang, what are the exceptions to this rule? Yeah, because if I'm not mistaken, I have encountered this kind of um this kind of a question before in the boards, o ano daw yung what will happen to your tissue sample if prolonged immersion in the reagent is done. Mga parang ganun. Yeah, to that effect. So, the answer is excessive shrinkage and hardening. Okay? Yes. Among the choices given is hardening. So, that's the correct one. Okay? What is the exception, or what are the exceptions to this rule? Exception would be your decalcifying agent. Because remember, if you immerse your tissue sample in your decalcifying agent for a prolonged period of time, what will be the result? Maceration of your tissue sample. Same is true when you immerse your tissue sample in low concentrations of alcohol. So what would be the effect? Maceration. Okay? But in general, it would be hardening and shrinkage. Okay? Prolonged immersion. There would also be an effect if there is an inadequate infiltration or impregnation. So that means the procedure performed was not complete. Yes, so the impregnation is not complete. Okay, yeah. So inadequate infiltration. So this will result to a soft. Okay, it will result to a soft and shrunken tissue sample. Okay, why will it become soft and shrunken? Remember, what step did we perform before this one, before paraffin impregnation? It's clearing. Okay, and what is the requirement as for the reagents that you use in clearing and the reagent that you use in infiltration? These two reagents, they have to be compatible. How would we know that they are compatible? They have to be miscible. Okay, miscible. Okay, they have to be miscible with one another. Particularly, your clearing agent, or your paraffin rather, should be miscible in the clearing agent. Otherwise, it will not be able to replace your clearing agent. Okay, miscible, again, it should dissolve. Okay, it should dissolve. And so, if you did not, or if infiltration is inadequate, it means that you did not remove the clearing agent completely, okay, from your tissue sample. And if that would be the case, what will happen if you are going to infiltrate it without completely removing your clearing agent, or if the clearing agent is still present in your tissue sample? What will happen to your paraffin? Your paraffin will dissolve. Okay, it will dissolve. That's why it will your tissue sample will become soft and shrunken. Okay, because you did not remove the clearing agent completely. Okay, when you perform infiltration, or when the paraffin is there in your tissue sample together with your clearing agent, then what happens to the paraffin? It will dissolve. It will not solidify. Okay, it will not solidify. It will be in its liquid form. Okay, it will be in its liquid form. That's why it's soft and shrunk. Okay, ayan. So that's why you have to perform your infiltration process completely. Okay, so apart from soft and shrunken tissues, other other observations which we can see in our tissue sample if infiltration is inadequate would be crumbling. Okay, so there would be crumbling of your tissue blocks during sectioning because it's not hard enough. Remember the microtome. The microtome is very heavy. The knife even that we use in microtomes, it's heavy. Okay, and so when you perform sectioning, what will happen to your block? It will crumble. It's not hard enough. It's soft because of the presence of your clearing agent, which dissolves your paraffin. Okay, why? Another observation is your sections will break up. Okay, break up. Your sections will tend to break up during flotation. Okay, so I repeat, breaking up of sections during flotation is another clue. Yes, it's another clue that there is inadequate infiltration. Okay, so I repeat, the clue aside sa clue. Manifestation, okay? It's another manifestation or it's another evidence that there is inadequate infiltration. Okay, so I repeat, what are the three manifestations of inadequate infiltration? Number one, soft and shrunken tissues. Number two, crumbling of tissue blocks during sectioning. And then lastly, breaking up of tissues, okay, of tissue sections during flotation. We have three, okay? Yan, yan, yan. Okay, next, yon. Okay. So another disadvantage of your paraffin, it is not recommended for fats. Okay, it is not recommended for fats or lipids. If you are supposed to demonstrate your lipids or fats for examination by the pathologist, then you should not make use of paraffin. The reason for this is not because of paraffin really. It is because of the steps that you produce tuloy. It is because of the steps that you perform prior to impregnation, paraffin impregnation. Remember, when we talk about paraffin impregnation, what is the fixative that is commonly used? We have formalin. Okay, formaldehyde, 10%. Okay, what is the dehydrating agent that we use? We have alcohol, ethanol. What is the clearing agent that we use? It's xylene. Okay, so all of these reagents are compatible, are used because later on we perform paraffin impregnation. Okay, they are compatible to paraffin impregnation. Okay, so that's why, just like what I mentioned, it's not really the paraffin, but the reagents that you use prior to your paraffin. Remember, alcohol dissolves lipids and fats, or okay, alcohol dissolves lipids or fats, right? Xylene, will it dissolve? Yes. Okay? Yan. So that's why it is not recommended for fats. Okay? Not recommended for fats. All right. Ayan. Okay. The problem with paraffin impregnation, okay, especially if we consider prolongation, okay, especially if we consider this disadvantage, okay. Um, for tissues which are difficult to infiltrate, we really need to perform prolonged infiltration or impregnation. Or rather, prolonged immersion in your paraffin is really needed for samples which are difficult to infiltrate. So what are examples of samples? Pangit. What are examples of specimens which are difficult to infiltrate? We have bones, okay, teeth, brain, eyes. Ulitin natin. We have tissues which are difficult to infiltrate, okay? Bones, teeth, brain, and then eyes. These tissues, they are difficult to infiltrate. That's why prolonged immersion is actually necessary. But please take note, for this four, okay, for paraffin impregnation, prolonged immersion is not advisable. Okay, nakuha? Yan, got it? Got it? Okay, prolonged immersion is not should not be done with paraffin impregnation. That's why if you're going to look at the other media that we use for processing samples, there are certain or there are specific medium which are actually recommended for this core. Okay, there is a medium recommended for bones and teeth. There is a medium recommended for brain samples. There is a medium recommended for eye samples. Okay, not paraffin. Not paraffin. Not paraffin. Okay, because prolonged immersion is needed, but you can perform that in paraffin impregnation. Okay, yan. So, yan po. Later on, we will be discussing the different media which may be utilized for these tissues which are difficult to infiltrate. Okay? All right. Yeah. So what are the different methods? Yeah, actually this is quite long pala. Yes, this is long. I would have to cut it maybe after methods. Okay, after paraffin embedding, I would have to cut it and then later let's proceed to, yeah, let's take a break and then I'll stream again later. Okay? Yan. After paraffin embedding, and then we will start with paraffin substitutes. Okay. Yan. So what are the different methods? Yes? Not yet. What are the different methods of paraffin impregnation? Okay. What are the different methods of paraffin impregnation? We have three. All right. We have three. The first one is manual impregnation. Okay. Manual paraffin impregnation. The requirement as for the temperature is 2 to 5 degrees Celsius higher than the melting point. Okay, 2 to 5 degrees Celsius higher than the melting point of the wax. Okay, what is the required number of changes? Four. Four. Okay, at 15 minutes, 15-minute interval. Okay, so four changes at 15-minute interval. And then embedding is carried out for 3 hours. Okay, embedding is carried out for 3 hours. Okay, do not be confused because when we were discussing the introductory part of paraffin, it says there, minimum requirement. Okay, minimum requirement as for the number of changes, it's 2. Two, we are talking about paraffin impregnation in general. We are not specifying the method. What method are we going to use? Hindi po natin in-specify yun kanina. Basta, okay, in paraffin impregnation, the minimum requirement is 2. Okay, 2 changes. Okay, but if you are performing paraffin impregnation manually, so the required number of changes would be 4. Okay, 4 changes. Okay, and embedding is performed 3 hours. Okay, complete embedding na po yan. All right, another, we can also perform automatic, okay, automatic paraffin impregnation. Again, the temperature of the oven, of the automatic processor rather, is set at least, okay, it should be at least 3% higher than the melting point of the wax. Okay, it should be 3% tuloy, 3 degrees Celsius higher than the melting point of the wax. Okay, so what is the required number of changes? We have 2 to 3 changes. And since we are making use of an automatic processor, it should be performed with agitation. Okay, so paraffin impregnation using your automatic procedure would involve the presence of agitation. Okay, the presence of agitation. Ayan. All right. So, the presence of agitation, okay, the presence of agitation during automatic processing, so this will actually improve and accelerate the penetration of your paraffin wax into your tissue sample, okay, into the spaces, into the cavities and interstices present in your tissue sample. So that's why an advantage of your automatic paraffin impregnation over your manual paraffin impregnation would be the results that you produce using your automatic would be more consistent. Okay, it would be more consistent because of the presence of agitation. Okay, and apart from that, since agitation will accelerate, okay, the penetration as well as improve the penetration, automatic processing requires less number of changes. Okay, so we have 2 to 3 changes as compared to the 4 changes required for manual processing. Okay. And then lastly, we have vacuum method. Okay, we have vacuum method. For vacuum method, the required temperature, okay, the required temperature is 2 to 4 degrees Celsius. We have 2 to 4 degrees Celsius higher than the melting point of the wax. Okay, so we have 2 to 4 degrees Celsius higher than the melting point of the wax. And as for the number of changes, okay, we have 3 changes at a negative pressure. So I repeat, 3 changes at a negative pressure. So when we say negative pressure, this is equal to vacuum. Okay, this is equal to vacuum. So the negative pressure that is present in your equipment is 400 to 500, 400 to 500 millimeter mercury. Okay, millimeter mercury. So the vacuum or the negative pressure that is present in this particular processing. So this will facilitate the easier removal of air bubbles as well as clearing agent, as well as the clearing agent that is present in your tissue sample. Okay, so I repeat, it facilitates easier removal of air bubbles and clearing agent from your tissue sample. Okay, so thus your vacuum method, okay, your vacuum method is considered to be the most rapid or the fastest paraffin wax impregnation. Okay, so I repeat, this is considered to be the most rapid method or the fastest method of paraffin wax. Okay, paraffin wax impregnation or infiltration. Okay, so how rapid is your vacuum method? So the time that is required for impregnation is reduced. Okay, so I repeat, the time that is required to perform impregnation is significantly reduced by 25 to 75%. Okay, so there is a reduction in the impregnation time by 25 to 75%. How is this significant? Of course, we can say that it's faster, it's, di ba? Time in the laboratory is a very important factor that we have to consider. So apart from reducing the time, okay, apart from reducing the time, another another effect of this, okay, another effect of this would be your tissue sample, your tissue sample is not overexposed, okay, or it is not exposed to heat for uh for 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 a long period of time as compared to when you perform automatic or manual processing. Okay, so I repeat, your tissue sample is not overexposed to heat. Okay, it is not overexposed to heat. So the different effects of heat will be prevented. So just like what we have mentioned a while back, overexposure or prolongation in your paraffin wax, what will be the effect? It will cause excessive shrinkage and hardness. Okay, but since you did not overexpose your tissue sample to heat, then um your tissue sample will not become shrunken. It will not shrink and it will not become hard. Okay? So I repeat, there will be no shrinkage and no hardness of your tissue sample because of the reduced time of impregnation. So apart from that, it has also been observed that that in using vacuum for paraffin impregnation, no brittleness is observed in your tissue sample. Okay? No brittleness is observed in your tissue sample. Actually, yun ang tinitignan natin when we perform infiltration. It's it's the exposure of your tissue sample to heat. Okay, yun yung kino-consider natin. Hindi naman dahil paraffin is damaging in itself. Okay, in itself, paraffin is actually not damaging to your tissue sample, but because you need heat in order to maintain the liquid nature of your paraffin, that is the one that is damaging to your tissue sample. It's the heat that is involved in the impregnation process. So if you reduce the time, you reduce the exposure of your tissue sample to heat, thereby no brittleness, no shrinkage, and no hardness, okay, in your tissue sample. Okay, yeah. So what are the applications of your vacuum? Vacuum, so this is utilized for urgent biopsies. I think this is understandable because it's the most rapid. So that's why you use it for urgent biopsies. Another, it can also be used for dense and fibrous tissues. Okay, dense and fibrous tissues. Remember, when I was talking about the disadvantages of paraffin impregnation, we encounter problems for tissue samples which are difficult to infiltrate, right? Okay, difficult to infiltrate because it would need longer time. But since your vacuum method, the time is already reduced, then you can perform or you can use this specific method for dense and fibrous tissues. Okay, so another, your vacuum method can also be utilized for delicate tissue samples. Examples of delicate tissue samples, we have lungs, eyes, and your spleen. Okay, lungs, eyes, and your spleen. Okay, yan. So those are the applications of of your vacuum method. Okay, so we are done. Next, we go to last two slides. Okay, next we go to paraffin embedding. I'm sorry. No, considerations first. Okay. So what are the different considerations? What are the different considerations when we are to make use of paraffin as our reagent? Okay, so the first one is the purity of your wax. Okay, so paraffin wax, you have to ensure that it is pure. Okay, that is pure. So how do we do that? So if you are using a fresh wax, so there is a need for you to filter your fresh paraffin wax at 2 degrees Celsius above the melting point of your wax. Okay, so I repeat, for fresh wax, you have to filter it at 2 degrees Celsius above the melting point of your wax. Okay, so if, for example, your wax, you are going to make use of wax from trimmings. Okay, wax from trimmings, you have to filter it with a coarse filter paper. Okay, coarse filter paper. A good example, a good example of a coarse paper, a good example of a coarse filter paper, we have greens. Okay. So, a good example would be your, kikita nyo ba? Okay, a good example would be your greens number 904. So, this is an example given in our book or in the book by Gregorius. Greens number 904. Greens number, as in number. Greens number 904. Okay, so that is an example of a coarse filter paper that is utilized to filter wax from trimmings. Okay? Yeah. So in order to remove any impurities or contaminants present in your wax. Okay? So one significant contamination which may be present in your sample would be water. So if water is present in your paraffin, so you just heat your paraffin wax to 100 to 105 degrees Celsius. Okay? So yan, we just allow it to evaporate. So remember the evaporation, tama ba ako? Evaporation point, boiling point. Ano ba yun? Okay, the boiling point of water, in order to evaporate water, we have to make use of its boiling point, which is 100 degrees Celsius. Okay? Yan, so to remove it completely from your paraffin, you have to boil it 100 to 105. 100 to 105 degrees Celsius. Okay, so how many times can you use your paraffin wax? So you can use your paraffin wax. You can use your paraffin wax twice. Okay, dalawang beses, twice. How many times can you reuse your paraffin wax? Once. Kailan mo pwedeng ulitin? Basta, ganun, parang ganun. Okay? How many times can you use? Twice. How many times can you reuse your paraffin wax? Once. Okay? So that's why it says here, you can actually make use of wax from trimmings. Okay? Yan. So, pwede pong gumamit ng wax from trimmings because you can reuse it once. Alright? Ayan. So, for paraffin embedding, so this is the last one for now. Okay, paraffin embedding. So, embedding, the required temperature of the melted paraffin for embedding, it should be 5 to 10 po. 5 to 10 degrees Celsius above the melting point of the wax. So I repeat, melted paraffin, it should be, the temperature should be 5 to 10 degrees Celsius above the melting point of the wax. Okay, and then after which, you can cool it by any of the following methods. We have refrigeration at -5 degrees Celsius, immersion in cold water, or if you are using, don't do that, madumi yan. If you are using tissue tech as your mold, there is already an incorporated cold plate for your tissue tech mold. Okay, so you don't have to perform the other two ways of cooling your paraffin. Okay, so yun, may cold plate na po yun. So again, refrigeration at -5 degrees Celsius, immersion in cold water, and with the use of your tissue tech, it already has a cold plate that is incorporated at the base. Okay, yeah. So those are the things that you have to remember for paraffin, impregnation, and embedding. Okay, so for paraffin, impregnation, and embedding. So I will end our discussion here. So let's end our, yeah, I will already end our, I will end our discussion at this point because it's too long already. It's 1 hour and 24 minutes, just like what we do in the laboratory. Di ba? Ganun naman talaga. So usually I discuss 2 hours or more. Yeah, it's usually more than 1 hour. Okay, so anyway, so I will already stop here. So I hope you can go back to this video if there are things that you missed or that are not clear. So if you have any questions, please feel free to comment or to leave a message in our group chat. Yes, in our Facebook group chat. Okay, so 감사합니다. Yes, nakakapagod pa na even for online discussions. Okay. So bye-bye. See you later again. See you later again. Yes, I wish to finish my histopath discussions today so that tomorrow and on Friday I can also concentrate on my other subjects. Okay, so thank you so much. I'll see you again later. Bye.